NASA's James Webb Space Telescope, JWST, has only just begun to open its eyes to the cosmos, but already it's unveiling a universe more mysterious, more beautiful, and more mind-bending than anything we ever imagined. What we once thought we knew about the universe might be completely wrong. Astrophysicist Adam Rees, a Nobel Prize winner, has raised an alarm. Our understanding of how the universe expands could be flawed. And with that comes a wave of excitement and curiosity about the strange discoveries lying ahead. Rees and his team have focused on something known as the Hubble constant, which measures the rate at which the universe is expanding. But here's where things get tricky. The new measurements from JWST don't match the older data, creating what scientists call Hubble tension. This isn't just an interesting scientific puzzle, it's a major problem that has been leaving experts scratching their heads for some time. Could it be that we've misunderstood the very nature of the universe's expansion? If so, it could change everything we thought we knew about the cosmos. But instead of clearing up these uncertainties, JWST's observations have only made things more confusing. The new data seems to confirm the old conflicting numbers, meaning that the universe isn't expanding the way we had believed. And it's not just a small mistake, this points to a far bigger issue. It might mean we've been overlooking something crucial about how the universe operates. Imagine putting together a jigsaw puzzle and realizing that some pieces don't belong, or that the whole thing might have been upside down from the start. This brings us to one of the biggest mysteries in modern cosmology: dark matter. For decades, dark matter has been the invisible substance that was thought to explain everything from how galaxies move to the behavior of gravity. It's like a hidden scaffolding, holding everything together. But now, JWST is throwing that theory into question. If dark matter doesn't exist, then what's keeping galaxies intact? Without it, everything starts to wobble, and we have no clear idea why. And then there's quantum physics, the unpredictable world where the laws of nature behave erratically on the tiniest scales. When you combine quantum uncertainty with the ever-changing universe we observe, it becomes clear why scientists are struggling to grasp the true nature of reality. But here's the exciting part: this confusion doesn't mean science is failing. Quite the opposite, it's a sign that science is working. We're not just accepting what we already know, we're being forced to question it. Every time we encounter something that doesn't fit, it pushes us closer to discovering something truly groundbreaking. Take, for instance, the very structure of the universe itself. JWST has revealed phenomena that contradict our long-held beliefs. Galaxies are appearing far earlier than expected, and some are bigger and more developed than they should be according to the current models. This doesn't just challenge our understanding of how galaxies evolve, it completely upends it. Some of the most distant galaxies appear fully formed, as if someone had pressed the fast-forward button on their development. And yet, we have no explanation for how this could happen. The mystery deepens when we think about dark matter. For years, it's been used to explain things like the way galaxies spin and how gravity holds everything together. But if dark matter doesn't exist, what is actually holding the galaxies in place? And why do we see strange movements that don't make sense according to the laws of physics we know? These are questions that JWST is forcing us to confront head-on, and they may change everything we thought we knew. But it's not just about galaxies and dark matter. The universe might not even be as uniform as we thought. Scientists once believed that the universe was isotropic, meaning that no matter which direction you looked, you'd see the same thing. But JWST's data shows something different. There are regions of the universe that look strikingly different from others. Galaxies in these regions behave in ways we don't fully understand, suggesting that the universe might not be as smooth and consistent as we assumed. This idea has led to new theories that the universe could have different currents, vast regions of space where things are expanding at different rates, or even contracting in some places. It's like the universe is a giant lava lamp, with clumps of space moving at different speeds, sometimes merging, sometimes separating. What if the universe isn't just one reality, but a patchwork of different regions, each with its own set of physical laws? And what if this is just a tiny part of a much larger cosmos, one with dimensions we can't even perceive? The idea of a multiverse, once dismissed as science fiction, is now gaining traction. The strange behavior we're observing might be the result of interactions with other universes or hidden dimensions. These ideas are starting to seem less outlandish as we uncover more evidence. The discovery of mature, massive galaxies that formed almost immediately after the Big Bang is particularly perplexing. In the Standard Model, galaxies are supposed to form gradually over billions of years. But JWST is showing us galaxies that look far too advanced for their age, as though they've skipped ahead in their development. This raises fundamental questions about how galaxies form and whether the entire timeline of the universe is different from what we thought. One of the key pieces of evidence we've relied on for understanding dark matter is gravitational lensing, which occurs when gravity bends light, allowing us to see distant objects. JWST's findings, however, show gravitational lensing that doesn't match up with the expected distribution of dark matter. It's like our map of the universe is full of wrong turns, and we're realizing that some of the directions we've been following might be leading us astray. Scientists are now exploring the possibility that our understanding of gravity itself might be incomplete. If dark matter doesn't exist, then gravity could be behaving differently than we thought. Some researchers are even investigating alternative theories of gravity to explain the strange behavior we are witnessing. These theories could change everything, suggesting that gravity isn't a constant force but something that evolves over time. As if that wasn't enough, the very constants of the universe, the speed of light, the force of gravity, are now being questioned. These constants were once thought to be unchanging, the backbone of our entire understanding of physics. But what if they've changed over time? Some recent observations hint at the possibility that constants like the fine structure constant may have been different billions of years ago. This idea could be revolutionary, reshaping everything from the smallest particles to the largest galaxies. The possibility that the laws of physics might not be constant is a huge deal, and it's pushing scientists to think bigger and bolder than ever before. Some theories even suggest that these changing constants could help us understand the mysteries of dark energy, and the accelerating expansion of the universe. Could the universe be evolving in ways we don't yet understand, and are these shifts in the fundamental constants the key to unlocking the deepest secrets of the cosmos? This idea also ties into the search for a unified theory of everything, which seeks to bridge the gap between quantum mechanics and general relativity. If we can understand how and why these constants change, it could help us bring together the two pillars of physics. In the end, this quest is about more than just understanding the universe, it's about uncovering the true nature of reality itself. The discoveries made by JWST aren't just minor tweaks to our understanding, they're forcing us to completely rethink the foundations of cosmology. Every new piece of data, every new image, is a step closer to discovering something that will reshape our entire view of the universe. The mysteries we're facing now aren't signs of failure, they're signs of progress. The universe is challenging us to think deeper, question everything we thought we knew, and push the boundaries of our understanding further than ever before. So, what's next? Whatever it is, it's sure to be mind-blowing. And as we continue to explore the cosmos, we're reminded that we've only just begun to scratch the surface of the greatest mystery of all, the universe itself.